Friday, we started with our intro to calculus, our intro to limits, and we learned a bunch of different things about finding limits. We learned that the limit of anything is always the y value. So we are always looking for a y value when we're approaching a certain x value, okay? So keep that in mind. A lot of you guys are forgetting that, or you're overthinking that. Again, your homework is going to be on the PDF that's loaded in Google Classroom. It is page 798. You're going to be doing numbers 1 through 19 odds, so like 1, 3, 5, 7, 9, all the way up to 19, just the odd numbers. Today we're going to be focusing on evaluating limits, just like we did on Friday, except there's going to be some cases where direct substitution doesn't work. You didn't see any of those cases on Friday because we gave you some special ones, you know, that always would work. Now, what happens when you try substitution, but what you plug in to find the limit makes the denominator 0? What happens in your calculator if you divide by 0? Error, right. Calculator freaks out, and that's because it's undefined when we have 0 in the denominator, okay? So what we got to do is we got to look at it graphically, because the graph tells all. The graph will tell us exactly what's going on. So when you have a graph, that's the best way to go, besides plugging stuff in. It's easier than plugging stuff in, just to look at the graph and see for yourself what the limit is going to be, if it exists. So we have this example here. We've got f of x, we have its graph, and we need to find the limit as x approaches 0 and the limit as x approaches 1. And we're going to look at each of those, okay? We're going to assume that we have the graph, and we're also going to try it if we didn't have the graph, okay? So we've got this function, and let's first find the limit as x approaches 0.
It's 1, right?
Yeah, so as x is approaching 0, because 0 is this x value right here at the origin, as we're approaching on the left and approaching on the right, we're approaching a y value of 1. So the graph makes it super easy. We can see right away that when we approach an x value of 0, the limit is going to be a 1. But what if you only had the function and you didn't know what the graph looked like and you didn't have a graphing calculator to see what it would look like? Then you would automatically go to direct substitution. So when we go to direct substitution, you have to plug in the number that x is approaching into your function. So let's try it. In this case, we'll have 0 minus 1 over 0 cubed minus 0 squared plus 0 minus 1. We'll clean that up. Got lots of zeros in there. What do I have left in the numerator and the denominator? Negative 1s, right, top and bottom. And what's negative 1 divided by itself? 1. Well, and that's exactly what we got. So that one worked. So direct substitution works there. You don't need the graph on that one, okay? But part B isn't going to be as easy. So let's look at the graph first. If we're following the graph and we're trying to see the limit as x is approaching a 1 this time, well, as we approach 1 on the left and the right, there's a hole there. But remember, we learned on Friday, the hole don't matter. It's still giving us the location of the y value. And the y value that it's approaching is a 1/2. So the limit as x approaches 1 of f of x is 1/2. So from the graph, we could clearly see what that limit is going to be. Okay, hopefully the graphs are getting a little bit better now. Okay. All right, and then let's try it though. What if we didn't have the graph? What if all we had was the function and we need to find the limit as x approaches 1? Just like the first part, we would plug in a 1 for all the x's in our function. So we would have 1 minus 1 over 1 cubed minus 1 squared, bless you, plus 1 minus 1. I know I had to take an allergy pill this morning. Allergies are so bad. All right, equals, well, 1 minus 1, we already know that that's 0. And yeah, 0 divided by anything is usually 0, but it's not anything. If we end up with a 0 in the denominator, that's going to change the outcome here. Do we end up with a 0 in the denominator?
Yes.
Yes, we do. We can't have that. This is a huge uh-oh. cannot divide by 0. Even though there's a 0 in the numerator as well, it doesn't matter. As soon as 0 ends up in the denominator, we have a problem. We can't do this, okay? So what happens here is direct substitution fails. But that's okay. That just means we have to go about it another way. So the other way that we're going to look at are these techniques right here. We've got some techniques for evaluating limits. These techniques are going to be very useful for when direct substitution fails. Okay? So these techniques, you don't have to use them all the time. It's only when you end up with a 0 in the denominator, you need to verify, is it really going to be a limit of D and E? Or is it really going to work and have a limit? And you always have to verify that. We can't automatically assume D and E now that we know there are cases where it may not be an actual does not exist answer. So the first technique is factoring and canceling. Factoring and canceling, these are, well, factoring and canceling stuff out. We've done this for so many years of algebra, especially first semester in this class. It was very heavy with the factoring and canceling when we were dealing with rationals. We learned a bunch of different techniques to factor this year. Rationalizing radicals is another technique. Pretty much you only need this technique if you see a radical anywhere in your function. And this is going to be a reversion, I don't know if that's a word, but it's going to be like reverse rationalizing what we've always done. You know how we always wanted to not have a rational in the denominator or a radical in the denominator? Well, now we want to put a radical in the denominator, and you're going to see why during this lesson.
So that way if it's like 9, or wait.
You'll see. But we're going to basically do the opposite of what we've always been taught to do. Because it's calculus, we have to look at things from a different point of view. And then graphing, using a graphing calculator. Now this one, you don't get to do this year. You will in calculus if you take it next year. So we're going to save this for calculus. Next year, if you are taking calculus, you're going to need a graphing calculator. They are expensive. They're at least 120 bucks. They're really expensive, but you'll be able to use that throughout your entire years of college, because you'll need it in college too, depending on your major. But lots of majors that involve the STEM pathways, which a lot of you guys are following, you're going to need a graphing calculator. Okay, so you might need to save up. You can find them on eBay for cheap.
Isn't there like a deal?
They have them on sale, but usually it wouldn't be anything less than $100. Yeah, they're expensive. They're expensive. But I was able to find mine on eBay, I think for $89, including the shipping. So it's a lot, but it was still cheaper than spending $120 full price on the same thing. So yeah, they hold their value, so you'll be able to resell it later on when you don't need it anymore. And you'll be able to get out most of what you paid into it, just so you know. Anyways, I'll show you guys mine. I'll bring it in so you guys can see which one I have. I really like mine. Anyways, okay, so now that we have these techniques, we can solve this part B now. We can figure out what the limit is using direct substitution. Yes, we already know what it is, but remember, we're assuming we don't have the picture of the graph, okay? So we're going to use the factoring and canceling technique because that would be the only option to use here. So we're going to take this function up here and we're going to show our work down below because there's like no room up above. So I'm going to rewrite it. Remember, we're trying to find the limit as x approaches 1 of that function, which is x minus 1 over x cubed minus x squared plus x minus 1.
How do you know that we're trying to find the limit of 1?
Because that was part B, the limit as x approaches 1 of f of x. Okay, so back in first semester, we learned how to factor by grouping. Remember, when we have 4 terms in a polynomial, we break it in half, we factor each side. When the stuff in the parentheses is the same, that meant we were doing it right, and that was one of the factors. The leftovers were the other factor. So this one's going to give us 2 factors here. Now, I'm going to show you guys a really cool shortcut. We're going to use the guess and check method to factor this. okay? Because if this equation, if this function has a limit, then whatever is making the denominator 0 needs to cancel out, because that's what the factoring and canceling technique is going to do for us. So the only thing that would cancel out is this x minus 1 that's in the numerator, because it's got to cancel with something in the numerator, right? So I know that an x minus 1 should be what is going to cancel. So that tells me already what one of the factors is going to be. You have to write the limit each time until you actually plug in the 1 the x is approaching, and then you won't have to write limit anymore. So once you finally take the limit, then you don't need to write limit anymore, okay? So it's going to come along for the ride, and we have an x minus 1 in the numerator. In the denominator, we're going to factor it using the guess and check method, like I just said. And we know that an x minus 1 needs to cancel, so there should be an x minus 1 down there, if it's going to work, okay? And we'll check to make sure. The other binomial, well, what do I multiply by x to get x cubed? X squared. So that one has to have an x squared in the front. Now let's focus on the last term of that.
Minus x, right?
Well, I need to get a negative 1. What do I multiply by negative 1 and still equal a negative 1? A positive 1.
Wait, but Miss Garcia, how do you get the x squared then?
Well, when we multiply it out, x times x squared is x cubed. X times 1, oh, there's my positive x. Negative 1 times x squared is negative x squared. And negative 1 times 1 is negative 1. So when we FOIL it out, it's going to work. That's the guess and check method. Now, if you want to do it the other way that we were doing all first semester, by all means. But this is going to save you some time because you already know that those x minus 1s are going to cancel. They divide out. So now I can rewrite this. The limit as x approaches 1. Remember, when stuff cancels, it does not turn to 0. It divided out, so it turns into 1. So I have 1 over x squared plus 1. And now the problem that was in the denominator that was making it 0 is gone. It canceled out. So now we can take that x value that it's approaching, that 1, and we could plug it in. We could substitute it in. So now I do not need to write limit anymore because I'm plugging in the 1. I'm taking the limit. So I'm going to have 1 over 1 squared plus 1. So what is that going to equal? 1 over 2. And isn't that what it showed on the graph? Yeah, that's what we got up here.
So wait, 1 squared is 0, right?
1 squared is 1.
Oh yeah, I do that.
Right. Any questions on that first example? So all we're really adding in there now is we're still finding the limit. It's still a y value. It will always be a y value, and I'll keep saying that. But now there's going to be times where we can't just go straight to plugging something in because we're going to get a 0 in the denominator. And if that happens, we have to approach it another way. All right, go ahead and turn the page to the back.
Oh.
And we're going to find the limit if it exists. Abby, this is for you. I'll give it to you later. Don't forget it though. All right, so we're going to find the limit if it exists, okay?
So can we try to direct substitute
Yes.
first, and if it doesn't work, then we do something?
Exactly, and that's what you got to do because direct substitution is going to be the quickest way when you don't have a graph, okay? But the best way to check to see if you need one of those new techniques is focus on the denominator. Exactly.
And it turns into 0. So.
Yep, negative 3 plus 3 is 0. So the denominator is going to equal 0, so we have a problem. We have to use one of those techniques. Now, to tell which one it is, it's either factoring and canceling or the reverse rationalizing. Well, you only reverse rationalize if there's a radical in there. There's no radicals in here, so it is the factoring and canceling. So we are going to need to factor and
cancel.
cancel.
Only factor the denominator, or would we
With the whole
factor
thing.
both?
The whole thing, top and bottom, because you need something to cancel. So in order for something to cancel, we have to factor top and bottom. So here we go. Remember, until we plug in that negative 3 at the end, we have to write a limit as x approaches negative 3 every single time until we actually finally plug it in. Now, just like the first example, the denominator is an x plus 3. That's what I need to cancel out because that's the problem. When I plug in a negative 3 plus 3 is 0, and it's making the denominator 0. I need that to go away. So I need it to cancel. So when I factor this quadratic, yes, we could use product sum and get there, but because I know that x plus 3 has to cancel, that means I know that one of the factors has to be an x plus 3. Has to. And then, of course, we're going to check it in our heads, to make sure. So now, to figure out the other part of that binomial, what times x gives me x squared?
Negative 2.
X.
Well, just the x for right now. But you're right. Once you find what makes the first term, then you need to find what makes the last term. We already have a 3, and then Faith and Tommy here said negative 2, and that's right, because 3 times negative 2 is negative 6. Now let's check it and make sure it really works. And we'll just do it in our heads. X times x is x squared. X times negative 2 would give us a negative 2x. 3 times x is a positive 3x. 3x minus 2x will give us that 1x, so that worked. And then 3 times negative 2 is that negative 6. So it works. We're good. So that means we can proceed. X plus 3's cancel. So now, this will be the last time we have to rewrite it. The limit as x approaches negative 3 of x minus 2. And now all we got to do is plug in that negative 3. When we plug in a negative 3, what are we going to get? Negative 5. Negative 3 minus 2 is negative 5. So that is our limit. So it did exist. It wasn't D and E because of the 0 in the denominator. It actually is a negative 5. Okay. So you can use the guess and check method like I said. If you prefer to use product sum like we've been doing most of this school year, feel free. Do what you are the most comfortable with. The more you do it, the more comfortable you're going to get with the shortcuts. So you have to allow yourselves to practice it in order to get there, though. Practice makes perfect. That might be an old saying, but it's a saying for a reason. All right, number 3, the limit as x approaches 2. Now again, we would check to see first in the denominator, is it going to make the denominator 0? Oh, there's no more x's. So I would just bust out a calculator and try it out here. 2 to the 3rd power, 2 times 2 times 2 is 8, minus 2 times 2 to the 2nd power is 4. 4 times negative 2 is a negative 8. Oh, so I already have a 0 there. And then plus 2 times 2 is 4, and then minus 4. Well, that's going to be 0. So we do get a 0 in the denominator. So we can't proceed by direct substitution, so we have to use one of those techniques. So we're going to be factoring and canceling again. Okay, so here we go. We got to write the limit, because we can't take it yet, of x minus 2 is in the numerator. And then in the denominator, since I know that something has to cancel, this time what should be in the denominator to cancel? X minus 2. So I know there should be an x minus 2 there in the denominator. So then we can guess and check. We've got a 4-term polynomial again. What do I multiply by x to get that first term, that x cubed? X squared. Now focus on the last term. You always just focus on the first and the last when you're guessing and checking. I need a negative 4. What times negative 2 will give me negative 4? A positive 2. And then we'll just check it in our heads really quick. X times x squared is x cubed. X times 2 is that positive 2x. Negative 2 times x squared is the negative 2x squared. And then negative 2 times 2 is negative 4. So it checks out. It works. So we can cancel out the x minus 2's.
And then we get 1 over x squared plus 2.
Yep. So now this will be the last time we write it, and like Cinda said, we get 1 over x squared plus 2. So now we can finally plug in that negative 3. So we're going to have 1 over Negative 3. Wait, is that a negative 3? Why did I put a 3?
Yeah.
It's a 2. Why did I put a 3? Oh my gosh. 2 squared plus 2. Sorry about that, you guys. That was just a random thing on my part. It's a 2, not a negative 3. That's what it says right here. All right, so this will be 1 over what?
6.
6. 2 squared is 4. 4 plus 2 is 6. So 1/6 is the limit. Okay.
Yeah, I did that one by myself.
Oh, you did? Yeah, feel free to work ahead once you guys have got it. You could totally do that.
One, 'cause there's a radical.
Yeah, that one's a new one for us. That next one, number 4, is a radical. So for our notes, I do want us to flip back to the front. This is what we're going to call reverse rationalizing. Mrs. Ardito coined this term. If you were to Google it, nothing's going to come up, at least nothing that pertains to what we're doing here. But this is what we call it because we're basically doing the opposite of what we've always been taught to do. Instead of getting rid of the radical in the denominator, we want to put it as a radical in the denominator. And the only example of this in your notes today is just going to be number 4, okay? So that's where that example is going to be located, just so when you're looking at your notes later on, if you forget, you know where everything is, okay? Because that's what your notes are for. You're supposed to use them as a tool to refer back to. Okay, so number 4, we've got a radical. We've got to handle this differently. We are not factoring and canceling. I mean, we are going to be canceling stuff. Because if it focuses in, if I were to plug in that 0 in for x, it's going to make it 0, right? So I can't proceed with direct substitution because that denominator is going to be 0 yet again. So I have to use one of the new techniques.
We're going to square both sides?
No. I know, we're thinking that we need to do that, but remember, we're not trying to get rid of a radical this time. We're trying to put one in the denominator. So I need to multiply the denominator by something that has a radical. So the trick for this, and we've used this trick a couple of times in the last unit and when we were dealing with complex numbers back in Math 2, it's called a conjugate. So I have to multiply by the conjugate, and I'm looking at the numerator because that's where the radical is. The conjugate means it's got the same stuff, but instead of a plus sign in the middle, it's going to have a minus sign in the middle. That would be its conjugate. So -1 minus the square root of x plus 1 is the conjugate of that numerator. But whatever I do to the top, I gotta do to the bottom.
Negative x.
No. Hang on there. I know you want to turbo speed ahead, but wait for me, okay? So what we're gonna do is we're gonna multiply the top and the bottom. Now in the bottom, you're gonna keep the junk in the trunk. And what I mean by that is you're not gonna distribute that x. You're gonna keep it exactly the same, just x in front of those parentheses. That's it. So when we write the limit, as x approaches 0 of all this, in the denominator, you're just gonna have x times -1 minus the square root of x plus 1. Keep the junk in the trunk. Don't mess with it. Because remember, what we're trying to do, our ultimate goal is get rid of what's in the denominator. That's the problem here, and that's that little old x. Because if we plug in a 0 into that x, that is what's making the denominator 0. We don't want that there. We want this x to go away. So what we got to do, and I like to put parentheses around that grouping there, we're going to have to FOIL it out, just like you would with a regular set of binomials. So -1 times -1 is 1. -1 times negative square root of x plus 1. Well, negative times negative is positive, so that's a positive square root of x plus 1. And then square root of x plus 1 times -1, that's a negative square root of x plus 1. Positive square root of x plus 1 times negative square root of x plus 1 is a negative square root of x plus 1 squared. And I'm writing it like that for a reason because I want to make sure we're taking it slow. I don't want to skip too many steps so that way you can have this in your notes. I think the light from outside is affecting my focus there. Okay, something happens in the numerator. What is it?
The negative x plus 1 cancel.
These cancel, right. Anytime you're multiplying by conjugates, the middle terms will always cancel. That's a difference of 2 perfect squares. That's what always happens. So there's that. And When we square a square root, what happens?
It comes out. So
The stuff comes out, right?
it'd be negative x plus 1.
No, it won't be negative x plus 1. It'll be negative x minus 1, right? So just to make sure that we're not skipping anything, let's bring down that 1. We know the middle term's canceled. I'm still going to put that minus there. But when I take the x plus 1 out of the radical because it was squared, I'm going to keep it in parentheses. Because what are you supposed to do with that negative? Distribute it. A lot of students forget to do that. So anytime you have more than one term, in this case, x plus 1, that's 2 terms. You have to put parentheses around it, especially if there's a negative in front of it. Okay, in the denominator, you keep the junk in the trunk. It has not changed. Okay, so when we simplify this on the next step, so limit as x approaches 0, we're going to have 1 minus x, and then what's going to happen to this plus 1? What's it going to become? Minus 1, right. So 1 minus 1, yeah, they're going to cancel.
You just get x, and then the x is...
Well, is it just x? It's a negative x. Keep the junk in the trunk. And now we can remove the problem so that we can come up with a solution. The problem was that x in the denominator. Well, now we can cancel them out. There will still be a negative 1 in the numerator, so we're going to have the limit as x approaches 0 of negative 1 over, and then the junk in the trunk now is just negative 1 minus the square root of x plus 1. But now the problem has been removed. I can go ahead and plug in 0 for the only x that's there now. So I'm going to have negative 1 over negative 1 minus the square root of 0 plus 1. What's the square root of 1? 1. So that'll be negative 1 over negative 1 minus 1. So that's going to be negative 1 over, what's the denominator going to be now? Negative 2. What's a negative divided by negative?
Positive. So
Positive.
1/2.
So it's just 1/2.
That was a long problem.
Yeah, but I didn't skip any steps. So guys, these ones, you're probably not going to like them at first, but once you recognize that some similar things are going to happen every single time, you won't need to write out every single little step, and these will be a lot quicker. But again, the only way to get there is to practice them. Practice makes perfect. Number 5, this one involves a complex fraction. We dealt with these in first semester, fraction over fraction, and we simplified those. Okay, and again, if we plug in a 0 for x in the denominator, we're going to get 0, obviously. So we have to use another way. So what we got to do is we got to get a common denominator. Okay, so to get a common denominator, we've learned that the only way to make two different things have something in common is to multiply them together. So another thing to mention is this 2 right here is not the same as the 2 over here. A lot of you guys make this mistake. Those are not the same 2's. One's just a 2. The other one is a 2 plus x. They're completely different. They're not the same. So to make this have the same denominator, I need to multiply top and bottom by a 2. And this one top and bottom by a 2 plus x. And you're basically going to simplify that all the way down until you can get rid of that x in the denominator. That's the problem. Okay? So we're going to have the limit as x approaches 0 of, in the numerator, remember the common denominator is a 2 and a 2 plus x. And then up here I'm going to have a 2. 2 times 1 is 2. Minus, and we have to distribute that negative 1 to the 2 and the x. So it'll be minus 2 minus x, okay, all over x. So you're basically going to simplify that down until you're able to plug in that 0. So I can't finish x, we only have a minute left, okay. All right, guys, so your homework is the page 798, numbers 1 through 19 odds on Google Classroom.
Where did you find the common denominator in the numerator if they're being multiplied?
They're not being multiplied, that's a minus. It's hard to tell, but that's just a minus sign right there.
Okay.
We're just subtracting.
Okay.
All right, you guys. I'll post a copy of my notes so that you guys can see that completely worked out.